Hello everyone, I hope you guys are having a great day so far, and I hope that you're kind of getting the hang of how I'm doing distance learning. I know it's probably a little bit different than what Mr. Fleck was doing, but I hope you're able to understand kind of the process of things and that you're able to be successful. Just a few things that I want you guys to be aware of. One, if you look on my Schoology page, I've posted a file that says Mrs. Hyatt's distance learning information, and on there it has my class schedule. So you can see when I have prep time, and it also has some information to get a hold of me. On that document it says if you would like to speak over the phone or do a Zoom call because you have specific questions, just email me first and we can set up a time to do that. But I'm more than happy to do that if you're really struggling or needing some help. So that's the first thing that I want you to be aware of. And then the second thing I want you to be aware of is that today, quiz 15.3, you'll notice it says quiz 15.3 and homework number 1 problems. So this is the first quiz that you're taking this chapter that is going to ask you questions directly from the homework. So make sure that you've done homework number 1 before you go and do that quiz, and check your answers on homework number 1 so you know that you're doing it the right way. So I forgot to do this slide the last time, but it's going to give you some helpful information for the quiz today. So there's 3 things that I want you to be aware of that affect solution formation. So when you're going and making your lemonade, you pour the powder in and almost everyone then sits there and stirs it. So that's what this means by agitation. Stirring or shaking increases the rate of dissolving. So that's a way that we can make something dissolve faster. Another way we can make something dissolve faster is through temperature. So yesterday, I made homemade lemonade for my family, and I wanted my sugar to dissolve faster rather than just stirring it. So I actually heated up some water on the stove and poured the sugar in, and that added heat made the sugar dissolve faster, and then I was able to cool it back down and pour it into my homemade lemonade mixture, and it tasted pretty good. So temperature is one way that we can increase the rate of solution formation. And then the last way is surface area. So if I gave you a cube of sugar, I don't know if you guys have ever seen cubes of sugar, but they make them in little cubes. That would dissolve a lot slower than if I gave you just like regular sugar, like the little grains of sugar. The little grains of sugar have a ton of surface area. So the smaller the particles, the more surface area there is, and so they will dissolve faster. So those are just 3 things that I want you to be aware of, 3 ways that we can increase the rate of dissolving or increase the rate of solution formation. Okay, moving on. Today we're learning about mass percent. So mass percent is a way for us to talk about solution composition. So what is a solution made of? One thing I want you to be aware of, remember again, that a solution has 2 parts. So I know we talked about this in an earlier video, but here we go. A solution is the solute plus the solvent. So those are the 2 parts that make up a solution. So if you look at mass percent is telling us the composition of a solution. It's telling us what makes up that solution and how much of it. So I think we'd all agree that we can have different concentrations of solutions. So if I'm making lemonade, which is a solution, I can have really tart and really strong and concentrated lemonade, or I can have really diluted and watered down lemonade. And so mass percent is one way that we can talk about the concentration of a solution. This formula right here is really important, so please make note of it. All of this right in here. Sorry, that is not my best highlighting job, but we're just going to go with it. Okay, so there's 2 ways to write it, and the reason that there's 2 ways to write it, if you notice here, it says the mass of solution is in the denominator. Down here, it just has grams of solute and grams of solvent. So that's just breaking up solution is equal to solute plus solvent. So that's why it's written 2 different ways. So we're going to be using this equation and this formula in the next 2 examples that we're going to do. Now I want you to be aware. Let me pick a different highlighter color. There are 3 things. 1, 2, 3. In all of these problems, you are going to be given 2 out of the 3, and you're going to be asked to solve for the 3rd algebraically. Okay? So keep that in mind. Let me go ahead and do that. Okay, example number 1. A solution is prepared by mixing 5 grams of salt in 100 grams of water. calculate the mass percent of salt in this solution. So basically we're making salt water and I'm asking you to tell me how concentrated it is. And again, mass percent is a way to measure concentration. So important information, 5 grams of salt, that's important. 100 grams of water, and it's asking, our question mark is, what is the mass percent? So how do you know which one is the solute and the solvent? Because the solute is what goes in the denominator. So this is a quiz question, I'll tell you that right now. The solute is always the smaller amount. The solvent is always the larger amount. So in this case, the 5 grams would be the solute, and the 100 grams would be the solvent. And it's important that you're able to identify that. So plugging that into our information, into our equation, the mass percent is equal to mass of the solute is 5 grams over mass of the solvent, or sorry, mass of the whole solution. So in this case, solution is solute plus solvent, and so we get 5 plus 100. And when you plug that into a calculator, oh, sorry, you also have to multiply, I'm forgetting steps here. You also have to multiply by 100 because it is a percentage. So when you plug that into a calculator, you get 4.76%. So that is the concentration of salt in my water. Okay, so next question. We're only doing 2 for the video today. This one is a little bit different. It says cows, oops, typo. My goodness, I am full of mistakes today. Cow's milk typically contains 4.5% by mass of lactose. Calculate the mass of lactose present in 175 grams of milk. So in this problem, we know the mass percent already. It told us that it's 4.75%. We also know the mass of the solution, and SOLN is an abbreviation for solution. Mass of the solution, the whole thing together, is the milk. That's 175 grams. So it's asking for the mass of lactose, which in this case, lactose is the solute. It's going to be the smaller one. Mass of solute equals, we don't know. That's our question mark. So if you look back at the equation up here, again, mass percent equals mass of solute over the mass of the solution times 100. So we come down here. We know the mass percent, it's 4.75 equals, we don't know the mass of the solute, so I'm going to say X, over the whole solution, 175 grams, times 100. So here is a quick tip for you and something I'm going to tell you to do that makes this a lot easier. Rather than going through all this math, I'm just going to ignore the 100%, and I need to first convert this percentage into a decimal. And remember, to convert a percentage into a decimal, you move the decimal place over 2 places. So it's right here, you go 1, 2, and then you put an extra 0 in. So anytime I am asking you to calculate the mass of the solute, you want to convert your percentage into a decimal. Okay, so I want to change that into a decimal. So now if we look at this problem, hopefully it'll be a little bit easier. It's 0.0475 equals x over 175. And to get x by itself, you have to do inverse operations. So this is divided by 175, so we're going to multiply it by 175. What you do to one side, you do to both sides. Okay, and let me change my pen color here. These will cancel out with each other. So then we just have to do 0.0475 times 175. And when you do that, you get 7.88. So that tells us that we have 7.88 grams of lactose. And we know that that's the right answer because if you remember on the last slide, our solute always has to be smaller than our solvent, or in this case we can kind of compare it to the solution. 7.88 is smaller than 175, so that would be a logical answer. So right now, go ahead and do homework number 2. It's posted in the folder for today. You won't have specific questions from homework number 2 until your next quiz, but please make sure you do it and check your answers and email me if you have any questions. Have a great day, guys.